Friends, subscribe my channel Netbook of Physics and press bell icon for latest update.
Hello students, in this session we are going to discuss about principle of projection of satellite. So we know that satellites are being launched from the Earth's surface and it revolves around the Earth in a particular orbit. So let us assume that this is the Earth which is having spherical shape. Suppose I have installed a tower quite high from the, as you compare the distance of the extent of the atmosphere from the surface of the Earth. Now suppose I am going to launch a satellite from this position. For launching the satellite, I have to give some horizontal velocity because my aim will be to make the satellite revolve in a particular orbit. Suppose I give a particular velocity v1. Now it will come and it will hit about this place. So we will not be able to make the satellite revolve about the Earth. So this is the place where it will hit. So this is my projection of the satellite. Now if I give another velocity, let's say that is v2, let's say it will come and hit over some other place, that is a2. Now at a certain velocity, at a certain horizontal velocity, it will make it to rotate about the surface of the Earth or about the Earth. So this particular velocity, the minimum amount of this velocity is the orbital velocity. So to make a particular satellite to revolve in a fixed orbit which is defined in a particular distance from the center of the Earth, we need to apply a particular horizontal velocity. Now suppose we are about to make it revolve just very near to the surface of the Earth, and it depends on your horizontal velocity, that from how far from the surface or the center of the Earth the satellite is going to revolve. So your horizontal velocity will decide. So initially you are just projecting the satellite. If your velocity is not sufficient to make it revolve about the Earth, it will come and it will just fall over here. So we call it as a range of projection. So horizontal velocity is directly proportional to range of projection. So we know, suppose we are going to make the satellite revolve at a particular distance h, let's say this distance is h, from the surface of the Earth, the orbital or the velocity of the satellite will be v, that is equals to square root of gm divided by r plus h, where r is the radius of the Earth and h is the distance of the satellite from the surface of the Earth. So we can call r plus h as a orbital radius for that particular satellite. Now the case we are interested in, suppose we are going to make the satellite revolve just very near to the surface of the Earth. So in that case we can write v, let's say this velocity of the satellite when it will about to revolve very near to the surface of the Earth be v dash. So in that case we can write v dash will be root over gm divided by r. So this is the particular value, of the orbital velocity of that satellite which is revolving very close to the Earth's surface, and if you put this value you will get the velocity will be about 7.93 km per second. So this particular velocity is called the first cosmic velocity. Now as the particular satellite is revolving, it is always under the effect or always under the influence of the force of gravity, and it is always tend to free fall. It is always in a position to free fall. So from this particular discussion we have understood that a satellite need a particular horizontal velocity for a bigger or for an accurate range of projection, or to make it revolve around the planet in a particular distance from the center of the Earth. Now for the successful launching as well as making the satellite revolve in a particular orbit, we need two types of velocities. So the first velocity is, these are the two essential things that need to be done, or two essential velocities that need to be taken care of to make a particular satellite revolve in a particular distance from the center of the earth. So first is to make the satellite to attain a particular altitude. So suppose you are going to launch the satellite from the particular height, because you can give the horizontal velocity from a particular height above the earth's surface only, and this is not feasible that you make a tower up to the height above the atmosphere. So for this you need to give a particular vertical velocity, that is we call escape velocity. So to make the satellite to attain a particular altitude, so we apply the escape velocity. So we need to apply the escape velocity first, and as the body or as the satellite has attained the required altitude, then we need particular horizontal velocity, that is we say as V orbital or orbital velocity. So we need the two velocities. The escape velocity is a perpendicular, or it is the vertical velocity which will be provided to the satellite to take it to a particular height h, or any height from where we want to project, and V orbital is that horizontal velocity with which we will start or will launch the satellite to make it revolve in a particular orbit. So in this video we have learned that the principle of projection of the satellite, what are the essential things that we need to take care of so as to make the satellite revolve around the planet in a particular circular orbit which is located at a particular distance from the surface of the planet also.